Hi guys, good evening. In this video actually I will be saying more about integration of multi-party computation with Ethereum virtual machine. You can't find much projects working on this or has not completed much things, but as of now you can find GCB EVM, which is garbled circuit based Ethereum virtual machine, where they are using MPC and they are integrating with EVM actually, and it's been deployed in COTI testnet. So this and you can find a lot of there will not be much information, but I have decoded what they have said in the videos, and I'm just trying to present that here, where how the MPC can be integrated with the blockchain. So here the thing is that this is the architecture where the user, I mean, this is the architecture where I have made it based on the videos that is there with SodaLabs. So the thing is that this is the Ethereum L1, and the user with the help of symmetric key, it is the inputs are being encrypted and the signatures are being generated, and which has been passed on into the validator, where the validator is divided into sequencer and executor, where the sequencer anyways it will only batch the transactions, but the executor, which is managing the MPC or which is interacting with the MPC here, that will be directly interacting, and based on the blocks, whether it's a red or black block, it will choose the MPC. Means that if you have integer data type, or what you say, the MPC based opcodes that's detected in the transaction which is part of the block, if that is there, then it will be passing on into the MPC circuit. Or else if it is not there and if it's a normal smart contract, then it will just do how it is executing the normal smart contract transactions. But before getting into the MPC, actually the MPC circuit actually, how it gets generated, it means that they are using garbled circuit. That means they are following the Yao's garbled paper, and the solidity opcodes before the transactions or before the EVM gets executed. Before that itself, the garbled circuits are getting generated, and possible input labels for those circuits are being generated based on the permutations, and they are also getting encoded based on the key. So in the system actually, for the evaluator, you will find only the entire system will contain only two type of keys. One is the symmetric key, and I mean one is the user key, and another one is the contract key or network key. So both of these two keys are being used to execute the MPC circuit here. So the thing is that yes, they are using symmetric key. That means that for each user you will need an what do you say, you'll need a separate private key for it. Otherwise people use like LGML encryption, public key encryptions and all. But they use here the symmetric key, where the each user has to be unique, and based on that the the evaluation happens here. Now the thing is that yes, once the garbled circuits are generated, it is getting spitted out to the evaluator. Let's say like one garbler, and another one is the evaluator here. So in the garbled circuit theorems, you can see that there is one garbler and there is one evaluator, or there is one garbler and there could be multiple evaluators, where the multiple evaluators or the evaluators are splitting the blocks which is being passed from the EVM, because of maybe the load balancing mechanisms, where if you have thousands of blocks and that has to be processed parallelly, then you need multiple evaluators. And before the evaluator executes those transactions, actually the garbled circuit has to be stored in the evaluator database, in the evaluator's environment here, and so that's why it is stored in the DB. And based on the opcodes that they get from the blocks, that is from the executor, that is being taken from the database and it's executing it. So based on the network keys and based on the keys that they have it, and the secret shares are being distributed between the evaluators here. And yeah, of course they will have the also, apart from the Boolean operations, they will have a way to execute the arithmetic operations, where they are using like OLE type of things, Of course, the OT needs to be used, like oblivious transfer has to be used. And apart from that, they have to use oblivious linear evaluation, where the arithmetic operations are getting executed, apart from the Boolean operations. So I will tell you in the next slide how that happens. Now here the evaluator decrypts it, and of course evaluator is decrypting and it is executing it, and they are doing the soldering of different opcodes here. That means that they are doing a pre-execution and they are doing an execution phase in the evaluator. So in the pre-execution phase, which means that they are establishing a wires between different opcodes that's written in the smart contract. Means that in your program, in your solidity program, if you have add and then if you have mux and then if you have subtract, then it finds a connection between it. It establishes a connection between the all these operations, and then it executes it so that the execution time will be reduced. That's what they are saying. Maybe they may change the design that we may have to you can subscribe to SodaLabs channel, and then you can find the new releases what they have it. So this is the interesting thing, where this is the only thing that you will find in internet where this is getting the MPC is getting integrated with EVM. But if you guys have found some other things, please let me know in the comment of which all MPC circuits are being used in EVM. But according to my knowledge, this is the only thing. So yes, at this point of time, this is the only circuit that's been integrated. And then yes, they are also integrating with the L2 Nitro, where the bisection protocol is being executed through the MPC circuit. So the bisection protocol is something like to find the difference between the fraud prover and the between the two parties actually. So challenging protocol, how that can be executed and all that is being passed on to MPC, which is off chain, which will reduce the cost here. So that's one of the intentions, and it is all publicly verifiable, because all the garbled circuits whichever it's been executed, this can be verified by any public wallet holder. And these all things are being, whatever the executions are happening, they are having the commitment, and that's getting published in the ledger, actually in the EVM ledger. So this can be verifiable. This is publicly verifiable here. So basically in the GC, in the garbled circuit based MPC, actually you will find garbler and the evaluator here, and the garbler is fully separated. In most cases actually garbler and evaluator are talking to each other every time, but this is the major achievement that they have done, where they have separated garbler from the evaluator. And I think that's one of the things where they are their TPS is going to increase, and it will be a good fit for them. So this is what it is. And then you can see that this is the soldering techniques, like when you have a transfer contract that's been written here, and if you have to do the soldering mechanisms between each and every opcode that's been written, like minus, plus, and boolean, then it's been all pre-executed before the actual execution starts here. So for GT is something like, yeah, greater than or equal, and addition, subtraction, the mux, that is the if else condition. These all gates are being stored before itself by the garbler, and the evaluator will be able to execute it based on the pre-execution wire that's been done by them. So basically they have the offline and online soldering. In the online soldering depends on the gas cost, how it can be, but in offline soldering the gas cost is very less here. So this is the basic architecture of the garbled circuit. It's a two-party thing. Means of course the evaluator will have multiple evaluators, and garblers will be able to spit out the garbled circuit to each evaluator based on the key that they have it. So each evaluator will have their own public key, and that will be identified, and based on that the garbler will be able to spit out, and that will be stored by each evaluator. And as you see here, these are all the keys, all the particular keys here. But A and B, it is without the help of evaluator itself, these all things can be done. But the OLE part, as I told you, the oblivious linear evaluation, that needs to be done through this OT protocol. oblivious transfer protocol, where the evaluator has to communicate, and then based on that they get this input, and based on that key and the inputs, this all calculations are done. So this is what how the GCEVM works, and if there is any new updates from them, then I will let you know. Thank you for watching.